Hey everyone, welcome to another stream for this Global Hack Week. Today we are featuring one of my favorite weeks, to be honest. GenAI, it's a topic that I've been like covering a lot on almost like all of my streams. I know we sometimes like talk about like APIs and databases, especially like MongoDB. But at least for this one, we're going to be doing something a little bit different. So we're basically going to be using YOLOE, which is a new model that YOLO just like dropped. And the reason why I decided to use this tool is because my robotics team was in a competition like very recently, and I got the chance to use this model, and I was like, like this is something that hackers might find interesting for like hacking projects or like hackathons as well. Hey there, I love to see the MLH stickers and the dinosaurs over there. Hi everyone. Cheese exams are over, so happy right now. Yeah, I had my finals like just last week, so it was a super intense week because we had to build a robot. It was like a tractor, and we had to use an STM32, which is like a developer board, and we had to code it using like C with bare metal. And bare metal is just like literally like configuring each register and like where the pin like it's going like to which direction, which peripheral I'm controlling, and it's just like shifting registers and like going a lot into like the buffer of the microcontroller. I would say it was like challenging, but I learned a lot. I mean, there was a lot of like midnight working, but it was fine. Um, so mad because I understood it gave me Git error. Um, in my personal experience, sometimes Android Studio, like at least on my older computer, when I started like coding and like just trying out like a lot of skills, like Android Studio, like every time like it opened, like it would take so much time like to load, and it was just like super stressing for me. So yeah, I get you on that side. Well, seeing that we are here, don't forget to check in. I've sent the link over on the chat to make sure you get your points for today's stream. At least for me, it's kind of late in Mexico time zone, at least the central time, which is like 10 p.m. So we'll be wrapping up by midnight. But still, I'm super excited to share all this knowledge and all these cool tools that we will be using today. Playing with microcontrollers, I input output at the port level sounds like loads of fun. Yeah, honestly, like I've been thinking on doing like streams about more robotics topics, such as like Charvel, because Charvel is another streamer that studies robotics. So like he gets me, and probably on my next stream, like depending on the team for Global Hack Week, I will see if like we can do some low level programming as well. Because we can also do it on like we don't need like the actual board. Like we can basically do it on a simulator like online. 6 a.m. morning. Wow, that's also early. Today I also woke up like super early, and now we're doing like um a long run for my day as well. Great. So let's get started. I had a slide deck prepared for you. I would say it's kind of short because we will just be basically viewing like understanding like the backbone of YOLO, and then we're going into a little bit of what zero shot is, and then finally we're going to be reading some of the documentation for YOLOE, and then I'm going to show you some results of what my robotics team basically achieved with this model. And by that time, we will also be doing our same code by running this model. Um, I will try to run it like locally, but I remember the last time that I ran it locally, like I had to download the model, and it was like a while. So I'll try it again on my computer and see if it's it's still like in there. If not, like I will just do it like on a Google Colab and just like wait there until it downloads. Yeah, Ross and MATLAB streams have been done a couple of times. Yeah, I know. Like Ross is sometimes like I wouldn't say complex, but like if it's the first time that you're using it or you're like understanding what publishers and subscribers and nodes are, it might be a little bit like overwhelming. At least it was for me. Like I just learned Rust like less than a year ago, and I always got like super overwhelmed by the documentation and all of the videos like online. And it wasn't until I actually started using it like on different projects that I realized that it's not that hard to like start using it. Will you discuss like AI agents? I mean, we won't be building like an AI agent. We will be basically using a branch of AI, which is called like Zero Shot. For AI agents, I will have a stream tomorrow where we will be building a calling tool for scheduling like calendar invites or like fetching like important information from like meetings in general, using like voice recognition and like autonomous calling, kind of like a call center, if you call it that way. So yeah. Hi there. Hi everyone. We will use Colab. Depends. So I will try to run it locally because I think I have like the model downloaded. In case I don't, because I don't remember if I deleted like that code, I need to actually like search it. We will be using Colab as well. Yeah, of course. We will have our coding exercise at the end. I promise it's like super easy. Honestly, YOLOE it's one of like the easiest things to like get started. So you should have no problems with that as well. Great. So let's get started. I think I already talked enough, but I didn't introduce myself at the beginning because probably some of you have already heard about me. So my name is Jocelyn, and I'm a coach here at Major League Hacking. I'm based in Mexico. Some of my fun facts: I love salsa dancing, which I've not done recently, at least on this semester, because I had like a ton of work and a ton of like extra things. I should definitely like get back to that. I also collect bee plushies, and a recent acquisition was like the Minecraft bees from like the McDonald's. So that was cool. I actually have two because like a friend gave it to me, so like they're very nice. Yeah, I also like neurotech. It will be also nice to give a stream about brain computer interfaces. So I'll probably think about that for next seasons. And I'm also a GitHub campus expert. So if you have a question about GitHub or the program itself, you can also reach out to me on Discord. You will have my username, so you can feel free to reach out over there. So today we're basically going to be doing, learning a little bit about YOLO's like background. Honestly, this is something that I also learned like quite recently. And then we're going to see a little bit about Zero Shot, and then we're going to understand like why YOLOE it's like so cool, like especially for robotics applications or even like some hackathon projects that use like hardware or at least like computer vision. This could be like super nice to have for your projects because like honestly I remember doing like hackathon projects where we did like object detection and we had to download like models that had like already classes predefined, but with YOLOE you can basically just give it a prompt and it will basically detect in base of like pre-trained classes the object that you want to like identify. You will see in a while what I mean with using like prompts or using like random tags to identify like your classes, because it's very different to regular object detection algorithms. Yeah, so I really like mechanical keyboards. Right now I'm using a Razer. It's a pink Razer, so it's like I don't know if I can like move it upwards. It's this one, and it's like super clicky because it has like the how do I call them, like the green keycaps. And then I also have a Nufi, which is also kind of like pink with white. It's also very soft. Like the typing, it's so smooth, so I like it so much. What does zero-shot computer vision model mean? That's a good question that we will answer on the following content of the stream. So hold on, I will reach that part soon. Yeah, I like mechanical keyboards. Honestly, I don't use them very often because I only sit here when I give streams. That's weird. But yeah. Great. So YOLO, what does it mean? YOLO, it's basically you only live once. I know we've all heard like you only live once, but this time it's like you only look once because we were talking about computer vision. I know it's like a funny name, but now you know what it means, so it's nice. YOLO, it's basically a set of models that will allow users to detect like objects in real time. um how this works, more like on the backside, is that there's like a single neural network that is performing like all the classification by itself. So like the prediction, the counting of the classes, and also the bounding box detection is all done using a neural network. And in there is just like an image of how it basically works, like a general overview. Like this is a car class, this is like a bicycle class, then there's some like traffic lights over there. So that's just identifying like objects at a large scale. Um, so we're going to see basically like a set of different steps of how this works. Honestly, this is just like for context. Like once you start using YOLO, like you don't even have to understand like these things to know what you're doing. Like at the end, YOLO is just like another model that you can use. So just think of it as if you were using like I don't know, like Gemini's API, like the LLM. So like you can only like query it, or you can do like a request to its API, but you don't need to understand what's like on the backside of like all of the back architecture of how LLMs work. Though it's nice to know like how the architecture is built, so you can have like a better understanding of the technologies that you are using as well. How do I see many images of X thing it was trained on? Yeah, another great question. We're basically going to follow like these steps that will determine, well, will basically like answer your question by itself. So the first thing that the model does is that it segments an image into smaller images. So it's just like basically dividing the image that you have as an input into like a grid of like different image. That's why here it says like S times S grid of input. So the image that you give the model, it will basically divide it into like smaller squares, which will be kind of like smaller images of itself. So that's like the first step. Then after that, each cell in the grid is responsible for detecting objects whose center falls inside it. I know this might sound kind of like confusing. Like, what does it even mean that a grid is like responsible for something? So basically, for each like small square that it's over here, it will have like a middle point. So like each cell in the grid will detect which object whose center falls inside it. Why do we care about where the center of the object is? So that's just basically knowing how many like boxes will the object like cover up. So in this case, like our dog, kind of like the center point might be like over here, and then from that center image, you can basically detect like all of the rest of the dog that's over here, which is just like kind of like these 8 squares that are over here. And yeah, each cell predicts B bounding boxes. So B is just like a variable, because each cell can predict like an amount of bounding boxes. And I think one, it's like the default, but you can like have more on them. So each bounding box or each like B, it's defined by a set of different components. So we have the X and Y, which are just like our coordinates. Then we have width, then we have height, and then we have confidence. So confidence is just basically like how confident the model is that there's like a car in there. So perhaps on this cell, like on the upper left corner, it might say like, oh, like this is zero confidence because like I'm not seeing like a car in here. But like perhaps on this like lower square, it will say like, oh, like this is like a 0.5 because I'm seeing like the red light over here. So that's just basically what confident means. Confidence, it's a value that goes from 0 to 1. 1 meaning that there's like 100% confidence, and 0 meaning that there's like no confidence at all. So like there's no chance that that is like an object in there. Great. So we have some questions on here. So not pixels. So for YOLO, it's not about pixels. It's more about a smaller images that the larger image is basically like chunked at. For pixels, it will be like, for example, if you were using like OpenCV and you wanted to detect like lines or like for yeah like lines for like autonomous cars, then in there you will care like about the pixels, because you will do like some transformations to the image. Like, I don't know, perhaps you change the image to grayscale, then you apply like like a Gaussian filter and so on. So like in there you would actually care about the pixels, but for YOLOE it's more about smaller versions of the image itself. For confidence, it uses fuzzy sets or just 0 and 1. So it can be any value between 0 and 1. So it can be like 0.2, it can be like 0.3, and so on. So it doesn't have to be like one or another, because then that will be kind of like limited, you know? But yeah, nice questions as well. Then there's this other concept called like intersection over union, which is just basically a formula that gives you the confidence of like how confident is your model for that a dog is on like those squares. So you can have like, I don't know, like three bounding boxes or like four bounding boxes that overlap each other. So with the IOU, you could basically determine like where the object is actually like located at. Then we're moving on to basically understanding like the two values that are given by this YOLO model. So there's value A, and value A is just basically like how do I call it? It's like a single class. So single class is just basically that you can have like different classes of the objects that you want to detect like on an image or on a set of images. So talking about like pets and animals, like I might have a class or a vector where I basically want to detect like five different classes. And for example, class one might be like dog, class two might be like cat, and so on. So then we will have this encoded vector, which will be like all of my classes. And then C would be the number of possible object classes. So just as I mentioned, like having like cat class number one, dog class number two, and so on. Also, something important to note here, only one class can be predicted per cell. So for example, if my model were to confuse this with a cat, then it will only make one prediction per cell. So if my model was like undecisive on what the image is, it won't output me like, oh, this can be a dog and also a cat. It will only output me like, oh, like this is a dog. So this is also a limitation, because like sometimes there might be like more objects like on one image that are kind of like overlapping, and there is where we can see like some confusions or some like mistakes when using like these types of models, because they're basically limited to make like only one prediction per cell. So we have another question in here. So IOU is not X boxes, but it can go through boxes. I'm not sure. Oh, you mean like the overlapping of like the if you mean like by the overlapping of like X boxes, then you are right. I don't know if that was like the question, but yeah. What else? Yeah, we already covered like the A variable, but there's also like the B variable. So B, we kind of like already covered it. So B is just basically like the bounding boxes that we have. And to obtain B, you basically have to like multiply the number of bounding boxes times the number of classes that you have. So assuming we have like five classes, or like five values, so you would do like a b times five to get like your b variable over here. Then here's just basically how it works, like all of the variables that we've seen and all of the concepts that we've seen like already. So with A and B, like on each cell outputs, we can combine it on a single formula to find the dimension of our vector. And the vector is just basically this number that it's in here. I think I cannot make it like bigger, but it's like it's a little bit fuzzy. It says like classification 0 0.1, 0 0.2, 0 0.1, and so on. So that's like my vector. That is a vector that I need in order to make like my large bounding box when the model is actually outputting something to the user. So all the things that I'm explaining right now, there are things that go like on the back of YOLO. So you don't have to like configure all of those parameters. You don't have to worry about that. So for YOLO, you only need to basically like train the model on like images. So like input like some images and then just tell YOLO like how many classes you have. So for example, I want to detect like cats, dogs, parrots, and so on. You only have to tell that, and the model will do all of these like bounding boxes connections, the confidence calculation, and so on by itself, and it would just output you an image like this. So just like a bounding box where the object that you wanted, it's like right there. Great. So yeah, as I mentioned, only one bounding box for each cell, which is a limitation. So my bounding box will be one. And then the image is split into a grid. And the cyan circle in here is what I was mentioning, that it's like the true center of the dog. And then the red one over there, it's kind of like its predicted value. And yeah, basically the center of the dog, or the cyan circle that's over here, will predict the bounding box and the class. So there are two things to predict in there. There's the bounding box, so like the square or rectangle that's enclosing our dog, and then the class. So it won't only like detect the whole object, but it will also identify it for a class. So it will either identify if it's like a cat or if it's like a dog. So imagining that my model has like 7 different classes. So for example, you can choose that your class 5 will be like dog. And if you only had like 2 classes, and you have like class number 1 will be my cat, and then class number 2 would be my dog. So that's basically all that you have to do to use YOLO. I know it's a lot of like technical like details. And here's more of like a summary of like all of the steps, kind of like in a more graphic manner. So we basically have like the system that detects as a regression problem. We have step number 1 in here, that is just basically dividing our image into smaller images of itself. And then for each grid, which is this one, the cell will predict B bounding boxes, so like how many bounding boxes are in there, and the confidence for those boxes. So it can be a number between like 0 and 1 to detect how confident the model is that in there you can find like the object that we're looking for. And then we have C, which is basically the class probability. So how probable is it for my model to identify that we have like a dog in there? And then at the end, those predictions are encoded as a format that it's in there. So the format that you're getting as an output, it's what the end user basically gets. So what I will get in case that I start running these types of models. So the final detections are something like this. So we are identifying a dog in here. We are then identifying the bicycle, and then we're identifying the white car that's like on the background. So you don't have to worry about like the middle steps that go in there, but now you can basically have like a reference of how it works. Honestly, the first time that I started using YOLO, like I never learned about this. Like I just started reading the documentation and trying to understand that it was just like to make like object detections, but I never like questioned myself on how it actually worked and what was like like on the background of all of all of those tasks in there. Yep. So, any questions about YOLO? On like a large scale, we're not going to be using um like YOLO general models, because there's like YOLO 1 through 11, I think. I think they just dropped like YOLO 12, which is like quite recent. We're going to be focusing on YOLO E today, which basically has to do with like zero shot object detection, which we're going to be looking at afterwards. Hey there, glad to see you back. Great. So for zero shot object detection, I'm pretty sure some of you have already heard like the word zero shot, not only in like computer vision, but also in like LLMs, because it's something that happens like a lot. So the concept zero shot is just basically like a technique that it's used by like people to allow a model to classify objects without like seeing those classes previously. So this is just like as if you were like a person and you would say like, oh, like that looks like a bird, or like if you see something that you've never seen before, you can basically like identify it from like previous things that you've seen before, or like your knowledge that you have like as a person. So for example, like if I see something that I've never seen, I might start thinking like, oh, like this looks like a tree, but it has like flowers, but it has like fruits in it. So then I start like thinking about different objects that are in there and try to find like a response to what I think that object might be. So this is just the steps that we follow as humans, as thinking as humans. But like machines basically use like different techniques to like replicate this kind of like knowledge form. So um, they could basically give you an answer of like an object that you want to find without having like previous knowledge on it. So how this works is that as working with computer vision, we usually like give our models like a lot of pictures, telling them like, oh, like this is a cup, this is coffee, this is like a bottle of Coke, this is like a flower, and so on. And we give it like a set of like large data sets to be working with. But what happens if like I introduce an object that my model has never seen before? Then my model is most probably like going to fail. That's why we basically use zero shot to like prevent that from happening. So our model can basically, I mean, not think by itself, but like provide you with a like more accurate answer in base of like things that the model has like seen before. So it will create a new class for it. In a way, yeah, because like you can basically detect like any class that you can imagine. So if we go on and try like YOLOE or like any zero shot object detection model, you can just like input it like anything that you might think of, and the model will try to do its best to like detect something like from an image itself, which is pretty cool. Yeah, I actually think it will be better if like for testing like YOLOE, we use like their own Google Colab, how do you call it? Like their own example, like from the docs, and then we'll start to replicate it like on our local to see if like we can do something about that. Perhaps like a dashboard or something. Like I'll see what we can do with those examples. So yeah, these types of models are basically very useful for autonomous systems, because like autonomous systems need to be like in contact and need to be aware of the environment and like how active it is. So imagine that you have like a robot that needs to detect like different types of things. Like what happens if like a new parameter comes like into the equation? Then like the robot will be like not able to respond like correctly to the new class that it has never seen before. So how this works is that we basically divide our categories for like identifying images in three different classes. So we have like the scene classes, so classes that the model has seen before. So for the case of YOLOE, so YOLOE has like a lot of classes that it is already like pre-trained from, which will be like our scene classes. And then like our unseen classes will be basically the ones that we that the model has not been trained for and has no context whatsoever. Then we also have an auxiliary information, which is just a semantic information or word embeddings. I like to call them like semantic embeddings, which are just basically like vectors of like the embeddings of the object that you're trying to detect. So in that way, it will be easier to like identify with something as well. This actually makes sense. This makes a lot of sense now. So for zero shot learning, as I already mentioned a little bit earlier, it's just basically that humans are able to perform these zero shot learning by ourselves because we are knowledgeable of our own like brain. So we basically have like a lot of classes of a lot of objects that we have seen earlier in our lifetimes. But like for example, what happens if I travel to somewhere that I've never been before? And perhaps I see like an animal that I've never seen before. So I might try to think like, oh, like this looks like a kind of like I don't know, like a chicken or something. And it might be something else, but like at least I will have like some idea of what it is. So in zero shot models, it's similar because the knowledge in this case is a labeled training set. So we have our labeled training set. So in here we have like a giraffe. We have, I think it's a goat, and then we also have a horse. And then due to semantic embeddings, we're able to plot our final answer into this two-dimensional space and plot our point on the new class over here. So why? Because a lamb, I mean, it looks like a giraffe, at least like the ears look like the giraffe, but it's not very related to a giraffe. So it's just basically like we leave that point like outside our cluster. Then it looks like a goat. Yeah, it kind of looks like a goat. I don't know if it looks like a horse. So yeah, horse is like not included as well. So probably the lamb relates like better with the goat. Yeah, it relates better with the goat. Great. So to wrap up zero shot models, we have the term semantic embeddings. So I'm pretty sure you've heard this a lot in like RAG systems and LLMs. I also like to talk about them like a lot. So semantic embeddings are just basically vector representations of class labels or descriptions. Yeah, it can also be like descriptions that capture the meaning on a high dimensional space. So high dimensional space is just like plotting things on a grid and just like knowing how close they are like from each other. So like in this case, we have our grid in here, and we have like bottle, then we have like apple, and then we have like pear. And if you look at it this way, so the pear and apple like kind of like relate themselves because like they're fruits, so they should be like near to each other. So they're not like overlapped because like the apple looks different. So they might be on the same category, but they look different, so they're not the same. And then the bottle, it's like all the way on the other end because like the bottle has nothing to do with like the pear. I mean, it looks similar, but it's not the same. So I have a question for you all, and will give you like 2 minutes to think about it. So like looking at this example and looking at, for example, like the apple, the pear, the bottle, like why do you think that even though like the pear and the bottle like look similar, because they're kind of like the similar shape and their colors are like similar, why do you think the semantic embeddings are not like related to each other? And do you think it has something to do with the word like semantic? I'll drop like this question on the chat as well while you think on an answer, and I'll be reading your answers once you post them on the chat as well. So do you think, no, actually, why Beer and bottle, even though the bottle. Yeah, I dropped a question on the chat. We haven't answered. Edges. Would you mind like adding more info on that so we can like read it through as well? I know it's like a long question and like don't be afraid to like just drop your comments on the chat. I just want to see like your insights, like what you're basically like understanding from the image. Great. So we have our first answer here. Semantic is about meaning. Fruit is similar. A bottle is very different. Yeah, exactly. Yep, that's. I like that answer. Like semantic is about meaning, and that's completely true. So, I think in like school, like we've seen like at least on like grammar and spelling classes, they usually like ask little students like first graders and so on like to identify like similar objects, for example like oh like close all of the fruits that you see on the image or like all of the animals or like I don't know like plants and things like that, you know. So that is just basically doing like semantics. So semantics is just basically clustering by definition and not by appearances or even like how the word looks like. Are they both categorized as fruit? So apple and pear, yes, but pear and bottle, no. That's something. And it's like nice to think about it because like semantic embeddings are basically present in everything related to like AI. So I'm not pretty sure when this started to be like more common because I know like embeddings were like earlier to like the AI boom, but I'm not pretty sure if like they were used for like different applications or if they were just like not good enough to do like these types of things. Because like this is just something like very interesting. The model looks at the edges, not the object name. The model looks at the edges, not the object name. Yeah, so like the name is like it's like irrelevant. Um, but like the name has like it doesn't care if a pear or apple in name, only what the edges look like. I mean, it cares about how the object looks like, but it also cares about the word itself. So like the word of the class, so like the name of the class, so like bottle and pear and apple, it's important for like the semantic embeddings and the zero shot models because that's the only way of knowing if like they relate to each other. So in this diagram over here on the right, we can basically see an example or like a breakdown of how like they are classified. So we have like our bigger entity. So we have like our entity, then we have two categories. So we have food and artifact. And then in food, we can have fruits and vegetables. So then on fruit, we have like apple and pear, but then like on vegetables, we have like pepper. And then on artifact, we have like the bottle. And these three can just like continue growing. Because like what happens if in this like model, what happens if I add um like I don't know, like a cup. So the cup will be basically be lying on the artifacts category. Why? Because a cup is not food, so it won't go on this side. And if you are seeing on this diagram, I basically don't care like how my object looks like. I rather care more about like the meaning of the word itself. So for example, for previous versions of YOLO, so like YOLO 12 through all the way through YOLO 1, like this was not an issue. So it will only base itself on how the object looked like, and it didn't care about the name of the class. But now with YOLOE, which is like a zero shot model, we actually care about the definition of my class rather on how the object looks like. I mean, it has something to do on how it looks like, but it cares more about the semantic embeddings rather than like how, like what color it is or like how it looks like and so on. Great. So now it's time to see a little bit about YOLOE. So this will be a super brief introduction. So YOLOE is just basically a zero-shot promotable YOLO model. So by this, I mean that it combines like zero-shot techniques, and you can also prompt the model to get like better answers. So this model is just basically designed for like open vocabulary. So you can basically like ask it to detect like whatever you want, and it will like segment it correctly. I mean, it has seen glass before, for example, but maybe not bottle, car glass, but it will always know it's glass. Yeah. Oh, yeah. So like if the YOLO is trained with like the glass class, then if you see like I don't know, like this base, it would say like, oh, this is glass, but like it also looks like a cup, so like it will also add it to like the cup classes as well. And with YOLOE, you can basically add a prompt, so I can like give it a class name that's called like glass cup, and it should be able to like identify it correctly as well. So I have like a video on the next slide that I think we should like at least see like some parts of it. I'm going to stop sharing like these slides, and I'll go to like my YouTube directly. Um, what else? Yeah, I've never like shared like a YouTube video before on a stream. Like this is actually like the first time that I'm doing this. But I just think like it's a nice video, and oh, yeah. So it'll be displaying. Let me now just move my screen over here so I can see your chat messages. And please let me know if like you're not hearing like the audio once I start like sharing my screen, because like sometimes like the audio just like won't hear. So just to make sure that it's working. Oh, I can actually share like a video file. I should have done that. But I think then I should have like downloaded the YouTube video, and like I really don't want to do that. So uh also share the system audio. Nice. There it is. Do you have any YOLOE notebooks on GitHub I can just run and try on Colab? Yeah, we're going to do that right after the video. So once we finish this, we're going to run the YOLOE's example, and then we're going to see how I use that on the robotics application, and then we're going to replicate like an example ourselves. Great. So we're not going to see like the whole video. We're just going to see like important parts, and I'll just do like some extra comments about this. So yeah, let me know if you're not able like to hear from it.
Update section with the new YOLOE model. We're both going to see the documentation, a few examples, and also how you can run it in your own code with also analytics. It's just a few lines of code. We can load in the model as we're used to. This is an open vocabulary model, but also real-time seeing anything. So it's basically just going to detect every single object in your environment that it can see in the video, in the image, and so on. And it will basically both give you the bounding box, segmentation mask, and we will also get the label. So we can label anything that you throw at it. It's open vocabulary. You don't have to have any data and so on. It's going to be slower compared to the other models where we need to go in and fine tune our models on our own custom data set. But this is really good for use cases where we just want to detect arbitrary objects. We can even prompt it, give text descriptions of what we want to go in and detect in our images.
Yeah, so that was basically what I meant by like you can just give it like a description, a class, or even like a prompt, and the YOLOE would basically like be able to identify like those objects correctly.
So let's just jump straight into the Autolytics documentation. If we go inside the model tab, we can see all the models that we have available. If you're familiar with the YOLO world model, it is kind of like similar to that. It's just a newer version and does improvements over the YOLO world 2 on the Coco dataset. You're going to read a bit more about it here, but it has some improvements over the YOLO world model. It has both better like average position, but also faster inference speed. So it can basically just run more frames faster on the same. I have a few videos that we're just going to run through. So we have this indoor environment of a living room from multiple different angles to see if it catches that. We have a video here with some animals, and we'll have this guy riding on top of a horse. I have a script. I basically just took the user example from the Ultralytics documentation. It's just a few lines of code, but here we also see how we can extract the results if you want to use it in your own applications and projects. So the first one here is the prompt free. It's just going to take everything and detect that. The second one is going to be a text prompt where we can guide it towards what it has to detect in the images. So I'm just going to comment this one here out. There we go. We import YOLOE from Ultralytics. We specify which of the
If you're seeing like on this section of code in here, it's where the guy it's like actually using um like the prompts or like the comments. It's doing like camel walking and also like black horse. So like you don't specifically need to use only like one word. Like you can use more words to like detect the classes that you have like over there.
models that we want to grab. It's going to download automatically in the first run. 100% sure that you have the new model, you have everything ready to go. So now we can see we have this one here. The only thing that we need to do is just Python and my script called run.py could be your project or your own script. We have like a cocktail table, carpet, switches.
Yeah, so like in there, it's just basically detecting like everything that it can, like just from the input video that this fellow over here basically like gave it. And the cool thing about it is that it gives you like the segmentation, so like the masks of the objects, and it also gives you like the bounding box and like the probability of like the that object being what you want. So like for example, this chair like might have like a zero point 0.8 probability of like being a chair. So this might be helpful for like different applications that you basically like um I don't know, like you might want to differ between the probabilities below like I don't know, like zero point 0.6. So like any object that it's below like zero point 0.6, like you might not like take it into consideration because like it might not be like good enough for your application. And the ones that are like on the upper end, then you might consider those as well. So we have a question over here. Is it possible to compare YOLO and YOLOE side by side, for example? Yeah, I mean the basically the major difference is like YOLO it's like a zero shot model which detects like unseen classes, and YOLOE needs to be trained with seen classes. Oh well, I this guy is Danish. I can hear it on his accent. I don't know. Like honestly, I don't know.
Bit back and forth between that one. We even segment the lamp all the way with the cable up to the ceiling. We have the shelves in the background. We even get some objects on the back of the shelves. So this is but without the PF. So this is the prompt free that's just gonna detect everything. The other one is our text prompt where we need to guide it as well. So we have the two examples. First of all, just do the camel walking, set the classes, model set classes, and then we can call a predict method again on the new video. We still just want to show it and also save it. Now we can show the confidence as well because we're only interested in pretty much the camels walking, not just everything that we can see in our image. So Python run. We swapped out the model, came up with a new use case for the text prompt. It's gonna download this model as well. This is only 67 megabytes. Like match your prompt with the detections that we're getting from the model.
Yeah, so what this person here basically said is that it basically going to take like your prompt and it's going to compare it to like the classes that it like previously has seen to try to like identify what you're looking for. So on this example, this person basically said like, oh, like I want to identify like camels walking. So let's see, like let's see.
So now after It has downloaded the model. We can see we have these camels walking around. We get a pretty nice segmentation.
So in there you basically have like the segmentation, and you have like the bounding boxes, and then you also have like the probability of that like object um being like a camel that it's actually walking. So sometimes it's like 0.67. We've seen that it also rose to like 0.80, but there are sometimes that it can go like below 0.37. Keep saying cats are persons. I need this for my surveillance camera to detect cats at night. Oh yeah, then this might be the right model for you.
Mask around it. Now we're also showing the confidence score, so that can be very useful as well. You can go in and do confidence thresholding. Again, we've just been running through a
Okay,
couple.
so this is like a more direct example of what I meant by writing like actual prompts. So this person over here just basically writing like man sitting on horse, and the output it's like amazing. So like the output it's just basically detecting like the person that it's like being like on top of like a black horse. So this is making like your predictions like more precise, instead of like detecting the horse and then detecting if the person is like near, and even like detecting if the horse it's actually like black. So like YOLOE just basically does this like all by itself in just like a few lines of code, and of course like having the models, the corresponding models for like YOLOE and stuff. Great. So I think that's enough for the video. Now it's time for us to actually test it. Why is it amazing if it's like 0.26? I'm pretty sure like if I continue like running this, it might increase like the probability score. Let's see.
Now we can probably see it with the cowboy hat. We have the black horse. Now we can see we get some misses and so on because it has to do this search between our text embedding and our image embedding when it gets.
Yeah, so like it's basically explaining that of course like it might not be perfect because it basically has to compare like so many things. But still it's like getting something. It somehow like gets there eventually. And honestly, this is like a hard prompt. Of course, like for easier prompts as just like identifying like horse or like person, it might be like much more easier and much faster as well. Awesome. So now let's move on to the part of learning about like YOLOE and like going through the docs about it as well. So let me pull up a new tab where we will be basically viewing this model. So I'm going to share with you this Ultralytics link on the chat as well. So in there, you will be basically be able to see like some of the examples. So in here we have like the text prompt, so we can identify like rocks, trees, rivers, animals, and we can see it like quite fair in here. Then we also have like a visual prompt, so things that look like boxes. You can also do like cross images, so things that basically like overlap it themselves. Then we also have like more text prompts such as like white hat, red hat, mustache, tie, and so on. We can also have like a handcrafted shape, or even like prompt free. So like basically detecting like anything that the model thing it's in there, which this is like kind of like amazing because it's detecting like a lot of things like in here. That's pretty cool as well. Great. So this is a video that we basically saw. This is kind of like a more dense form of like the architecture itself. So I'm not going to go over all of this, but there are some things in here that we basically saw already. So we basically saw how the segmentation was done. Then we will also learn a little bit about the embeddings that are used and how the classification like affects the different semantic embeddings that we have. And of course, we need a text encoder to convert like our prompts into actual number vectors. And then we can basically get our different classes from here. So like man, horse, dog, and so on. So it's similar. The prompt embedding, it's like on this vector. So like everything just basically meets on this point like over here. So I know it might look like a lot, but it right now we just basically need to like understand how to run this already. So let me make this smaller and let's go to the examples now. So let me see if there's like a remember there's like a Google link over here like somewhere. If not, like I can just like open up a new VS Code and like start doing it from there. Oh, let me do. Mm, prompt free. This looks nice to try. Let's see if we can try like the first one just to see like. Oh well, I think this one's for the fine tuning, predict usage. Nope. Let's try. Um, let me see. Let's try this one. Um, but like then I will need this one. Let me see if there's another one. Launching training from scratch. Nope, I don't want to do that. The comparison as well with other models. Because like there's different versions of YOLOE that you can basically download. L usually means that it's like a large one that it will take like more to download. I think the table was like over here somewhere. Mm, no. Well, let's try running these already because I don't know how much time would it will take like for the model to download. So before I actually go and open up like a new VS Code tab, I'm going to share a GitHub repo where I will be posting like these code examples. You can basically find them like on the link that I sent, but in case like I do modifications or like we actually build like our own dashboard, then it might be helpful if like you also follow along like on the GitHub as well. Oh, it's this one. So I'm just going to go ahead and clone this one. There we go. Awesome. So clone Git repository, and let's just wait for it to like stop finish loading. And I'm going to make my screen bigger so like you can see the code because like from previous streams, like I think my screen was like at least like small to see, especially when like you're doing code. So just to keep that on mind in there. What should I call it? YOLO E test. Global Hack Week. I have like a random question like for the chat. What was the last hackathon that you all been to? Like even it's if it's not like MLH hackathon because I know there's like some hackathons that are not like on MLH League. Honestly, I'm just curious because I like want to learn like which hackathons are like cool to go to and you know or even like to recommend to like friends and so on. At least the last one that I went was the Hack for Her one, which was actually like on my city. So it was cool. There was a lot of nice food and people. Hugging Face. There was a Hugging Face hackathon. Wow, that's impressive that you actually like participated there. Hugging Face, it's so nice. Like there's a lot of like free tools and free models like that are like open source in there. That's nice. Well, I'll create a new file that's going to be called YOLOE um, prompt.py. And then I'll just go back to the code that we have had as an example in here and just copy paste this over here. So let's see. Paste. There was a Lerobot one. I've not heard of that one. That sounds good actually. Great. So let me just create a new Python environment so like I can start downloading Ultralytics again. I think Ultralytics like actually takes a while to like download. I'm not sure. Like I don't remember the last time that I actually like used it. So let's just start doing this one over here. Hmm. Now the virtual environment is actually like taking longer in here. Longer and longer. Great, there it is. So I'll just create a new terminal for it to take effect. And let's install Ultralytics. So I'm assuming it's pip install Ultralytics. I spelled that correctly? Yeah, there we go. So while that is happening, I'm going to look for images that we can like actually detect. So now I'm wondering, like the person from the video like actually used like actual videos for this. So like that might also be an option. I'm going to search mm, for a messy desk. Let's look for messy desks to see how many things the model can like identify from a desk. This one looks nice. Mm, this one looks like real enough to like be someone's desk. So I'm going to call it messy desk. And then I'm just going to add it on my local. So downloads. Oh, I actually forgot to share with you like the Discord. I'm sorry, the Discord, the GitHub link. So let me actually share that with you all. So the GitHub is also nice because like in here I basically place like the YouTube recording, and I also place the slides and like the YOLOE docs in case you also want to take a look on that. So yeah, in case that you are wondering, you'll find like all of the code and all of the content. I usually like to do this because sometimes like on streams like we might lose like the links that we send over like on the chat. So in here you will always find like all of the content, at least for our sessions and the streams that I give to you all on Global Hack Weeks. Great. So Ultralytics is still taking a while, so I'll just give it some time to like think, and then I'll start looking to search like for the actual code for the robotics thing that I mentioned. So let me go to my main GitHub page. Make this bigger. I think it's over here, so it's called like Home 2. So a little bit of context on the robotics thing. The competition is just basically doing like an autonomous robot that it's like a friendly home assistant. So it's kind of like a butler for your home. So you can basically tell the robot like, oh, like go and get me like water from the refrigerator, and the robot should be able to like navigate towards the kitchen, like open up the refrigerator, grab the water for you, and deliver it to you. And there's a lot of tasks that are like involved in there. So we have like the computer vision area, we also have like the human robot interaction part where all of the AI stuff like goes in. Then we also have like navigation, we also have like integration for like integrating like all of our components. We also have manipulation for like the X arm, which is like a six degree of freedom robot arm. So navigation, I'm sorry, manipulation is just basically to control like that arm. And I basically work on the computer vision and human robot interaction part of the project, but it's still interesting to see like everything else. So I'm just going to go here and search for YOLOE. So here we go. We have YOLOE detector. If you're noting in here, we are basically using like how do you call it, raws. So these are like different classes that we need to have like our raw system like working. So this code is just basically to identify like the different bounding boxes from the actual like image from your computer. Let me see where the classes are. I'm not seeing the classes in here. Yeah, we also have like the confidence because we can also like basically we can extract the confidence like from there as well. Let's see if Ultralytics is done. Oh my god, it's still installing. Um, wow, that's taking a while. So let's take a short break because I want to go grab some water, and then I'll come back once the Ultralytics thing like finishes loading up. I'll see you in about like 3 minutes, 5 minutes max. Hey there. We're back. Just wanted to have like some water because my throat was getting like super dry. Let me remove the banner real quick. Try cola. It will still like take a while to download the model. Like even if I'm doing it like on Colab as well. Do you all follow the code side by side? No, because I we haven't like run it like already. This is just basically like the example that I grabbed from the documentation. We're just basically importing like our YOLOE. We're selecting the model that we want to use. Then we are writing like our labels, and then we're just basically setting our classes depending on the array of classes that we have over here. And we're finally telling it like which image we want to like classify on, which in my case it will be messy desks dot gpg. So messy then slash desk dot gpg, and we're finally going to show like our results in here. So let's try running this because I think it will like start downloading like this model in here. So let's just give it a while in there. Mhm. I mean, it's going fast, so like it shouldn't be an issue now. Yeah, because I remember I was like downloading this with mobile data because like we didn't have internet connection where like near where the competition was, so it was like super stressful to be like running this in there as well. There it is. Oh, it didn't found like the ultralytics requirement. Oh, I think we need to download the clip thing. I think it was already successfully installed. Restart runtime or run commands to take effect. Yep, now it's downloading the other thing over there. So in the meantime, I'm going to be adding these to the git ignore. So like we make sure that I don't upload that to the GitHub repository. So copy path because the name is like super weird, and then I'll just add this in here. Wow, this is like a lot. There we go. Then this one over here, which is copy relative path. There we go. So in the meantime, while this is downloading, I'm going to try to search for the other example. I'm just going to open like a new window over here and enter that repository in here. So more, then we have home 2. Mm, so this is HRI. Then we have, looking object detect. Oh, my BS code bets. Object detector to the scripts. Yep, here's the zero shot object detector. Yeah, this is actually like the Rust class, but it's not. I'm going to close this because I don't want to like overwhelm you. Close. This still like on 30%. Mm, I'll start uploading these to the GitHub. So like added simple prompt example. And in the meantime, as we have like some time left, and I don't really want to lose time while this is like waiting. I'm going to start building like the dashboard where we can basically like display like our results depending like on the image that we basically like upload. So to use that, we're going to use a Streamlit as I always like to use it for specifically when I want to focus more on like the back end of the application. So I'm just going to go ahead and search like for Streamlit. In case you've never like used this before, just basically a nice it's a nice library used for building like web apps and applications using like Python code. So it's very nice and it's also like super easy to get started on here. So I'm just going to share the documentation link over there. We basically have to install it as well using command line. So we can try this over here. So we can try pip install Streamlit, then to run the basic app. And if it doesn't work, then we have to run our application using this command over here. So I can start building our dashboard. So I'm just going to create like a new file, and I'm going to call it like app.py. And then I'll just start like importing Streamlit. So import Streamlit as SD. And then what else? I'm going to start writing like a title. So SD dot title. And then my title will be like test YOLOE out. And then what we're basically going to do is that we're going to let the user like upload an image. So we're just going to add like a small description that's going to be called like write, and then we're going to tell it like upload an image to detect classes. And then before that, actually, we're also going to ask the user on a text input to like text input to actually like write the classes that it wants to detect like from the different images. Will we get the dashboard code on GitHub? Yeah, I'm going to make another commit once I run this, so you can also like try it out in there. Or you can also try like doing the code right now. It's just like super simple lines. Like it's not like so complicated. So as text input, we're going to type as label like write the classes that you want to detect. That's it. So as FYI here, we need to how do I call this? We need to store these results somewhere. So I'm just going to add this to like to a variable. So I'm going to call it my classes, and then just make equal. So now on my classes, I will have the classes that I want. And for the upload an image, I'm going to do a file upload section. But I need to remember how like the method was called. So I'm going to open up a new terminal and install Streamlit. So sorry, pip install Streamlit. There it goes. I think it was like already there. Honestly, I think like Streamlit, I will make it like a global install because like I always use it. So I don't think like virtual environment, perhaps for this project, like was not very necessary. Because now like I knew I had like Ultralytics installed, but perhaps like in another environment, yeah. But well, Streamlit is like downloaded now, so we can actually start running this dashboard so you can see like how it looks like. So to run our app, we're going to do Streamlit run, and then the name of my file, and the name of my file is app.py. So this is running on a new tab. I'm going to move it up over here so you can also see it. So it says like test YOLOE out, and then I can type in here the classes like hello, well, not hello, like cat, dog, plant, and so on. And then I think in here I'm missing like a button where I click and the results are like saved, and also like the section to like upload a file. So I'm going to go back there and I'm going to add those components as well. So for my classes, I need I mean, I don't actually like need it, but um I'll just leave it like that. Yeah, let's detect hello. We can try it with an image of like someone waving, just to see like what happens. Yep. So let me do the file upload here. So it will be like SD and file uploader. Let's see what this has. So there's a label. So we can actually like delete this. So we can add this here like on our label. So labeling here. Um, then what else? We also have the type, accept multiple files. So we can do this as a sequence string. So we can do like GPG. What? Yeah, we can do like GPG. And I think that's all we need. Yeah. Just give me a second to close my door because like my dog started like oh, there we go. I have like a golden retriever and like she's like super big, and then I also have like a Shih Tzu which is like small. She sometimes appears on my streams. I think she was here like a while ago, but now like she disappeared. Apparently. But yeah. Great. So let's see the file uploader. Um, so if I refresh these, now I'm able to like upload my files and like actually pass them like somewhere. Great. So the file, I'm not sure if like this is legal. I'm going to like search it in a while to see if like this actually works, but I'm going to pass it on as like um, my file to see if like this actually works. I don't know, but like let's just try it. And then in here, I'm just basically going to click like on a button. So like if my st dot button um, detect, well, no, I'm going to call it launch YOLOE. And then in here, I'm going to call my YOLOE call YOLOE method. And then if it's successful, then I'm going to print like a success button. So like success, I'm sorry, like success message, like classes detected. And then if it's like not successful, um, well, if it's like none, then I'm going to do like please like write an input. I'm sorry, like SD warning, and then like please type an input. There we go. So let's see how our model is. Great. I think it was like downloaded now. So let's actually start. Let's try running like the example code that we had like over here. Oh, I think it's not going to detect anything because like I left it as to like person and boss. But like, let's see. Yeah, like it didn't detect anything. So let me close this and let's type in chair and paper. Yeah, let's try that. What did it output? Oh, there it is. So now we have our chair here. We have paper in here. Even though like I'm seeing more paper like on the rest of the screen. So let's try with like files. Let's see if like files work. So like paper, we can also type with files or like I don't know, like on documents. Let's see if some of those like actually work. Wow, like there was like zero improvement in there. Let's try adding like computer in there. So computer. Hmm. Now this is actually like concerning. Mm, let's see the logs in here. YOLOE 2022 I don't think it's getting like the correct predictions. Like That's super weird. Like, what if I just delete like all of this and just type like person again, just to make sure that it's not like the code or like my computer. It might be just like a skill issue. Yeah, it's like a skill issue from the model that it's not like detecting the computer. Perhaps this is a challenging image for YOLOE. YOLOE, it's not ready for messy desks. Let's try with a red box. I'm clearly seeing like a red box over there, so I'm just going to try with red box over here. Let's try with that. So that was actually detected, like it actually saw like a red box. Let's try with plant. I mean, this is a plant, but I'm not sure if it will be able to like detect it correctly. So let's try with plant. And after this, I'll just create like a Python function to see if like we can run it like on our dashboard. Nice. So like it actually grabbed the plant over here. It kind of like detected as two plants because like the image is not like complete, but yeah. Should I try with computers? Try with computer screen? Let me try with that. So computer screen and also monitor. Computer screen and monitor. Let's try with that. Yeah, it actually works like for monitor with like 0.66. That's nice. I mean, this is all just like the semantic embeddings. It's just honestly how they work. So it's basically trying to find like the most similar meaning that I'm actually like inputting to like the model. So let me basically convert all of this into a Python function. So let's just do like def and then detect detect classes. And then I'm going to pass on two things. So I'm going to pass on my class names, and then I'm also going to pass on the image. So ah, image path over there, and then I'll just select all of it, and I'm going to tab. As a result, mm, I think we'll have to use a Streamlit over here to do like an image show. I'm not sure if that's a thing on Streamlit. Let me actually import Streamlit here so we can try it. So let's see, sd dot show, no, show image perhaps, and then what do I need to pass on here? Caption. Um, where's the wait? A URL string for a hosted image, a path to a local image file. Hmm. Let's try just like doing it directly, and if it doesn't work, um, then we might want to save like the image, or even like just like print the results out. That might also work as well. So like what will happen if like we print the results in here? So like let's do like some print and then like results. Let's see what happens. So I just want to see like the try Jello page. Yeah, let's try that. Hmm. Uh, I think it was running, but like I didn't see any image like pop up. So I'm just going to add like Jello page here. And let me run this again. Oh, I'm so dumb. Like I'm not even calling the function. Detect classes over here, and I'm just going to delete, copy paste all of these in here. Oh, but class names needs to be like an array, so I'm just going to add that. For arrays in Python, it's is it like int and then just, I'm sorry, like string. Is that a thing? Honestly, I don't remember. Um, I'm more of a Java person, so let's just do these like on the meantime. I'll delete the input streams, the input, the string, and then I'll search for it online. Um, detect classes. I'm just going to pass on like, I don't know, like random, and then like on image, random again. Let's try it like that. Hmm. There it is. Oh, yellow page actually worked. That was a nice one. That was a nice prompt. So we have monitor, we have yellow page, some yellow pages over here. Perhaps if we try with folders or like binder, it might work as well. Yeah, it might work as well. Yeah, we have like our list of images here. And then it actually printed like all of the arrays like for the bounding boxes. So like we have our names in here, and then we have like for each class. So like 0, it's like our first class. Then we have plant with our second class, and then we have like our array of like all of the dimensions for like the bounding box in case like we want to plot it in there. Oh, and then it actually did like the pre-process, interference, and post-process. That is new, actually. And it is basically saving my results. So that's interesting. There's a question over here. How can I use batch processing to get it to label images in bulk? Mm. Honestly, I think it depends more on your computer or your like computation resources. Because you can basically just type in like as much classes as you want, but as the model is running like locally, then it basically depends on like how capable your computer is like for running it. Also, can you try without text prompt and get zero shot to the text by itself? Yeah, we can try that. So let me go back to the docs. I think there was also like an example in there. I actually have never run like the prompt free one. So let's just see what happens. Like I think it's going to be like super messy. So I'm just going to create a new one that I'm going to call it YOLOE, and I'm going to call it like free dot py. And then here just basically messy desk. There we go. So let's try this one. What? No, don't tell me it's using like a different one. I mean, it's fast, uh, so this was YOLO E. Yeah, it's different. This is like PF. What's the difference between like PF and like the other one that I have? Let me look at the docs on that. YOLOE also includes prompt-free variants that come with a built-in vocabulary. These models don't require any prompts and work like traditional YOLO models. Oh, look, here are the list of classes that the model was like basically trained on. So we can see them like over here. So like 3D CG rendering, that's like a super specific one. Then let's scroll down randomly. Basement, basil, basin, basket container. So all of these like dictionary of like words, it's just basically uh what it is referring to when it's doing like the semantic search. So like if I were to search like, oh my god. So this is like manuscript. We have a can in here, which makes no sense. We have a handbag. Hmm, I mean that's a telephone, so no. Monitor, it's like a good a good accuracy. Oh, houseplant was actually detected better. And houseplant is like more specific. Then we have storage box. The office desk was detected like super nice. We also have a cup in there. I'm not sure if there was a cup in there. There's another. There was a backpack in there. That's true. And there's also a chair that was like nicely detected. Notepad in here. That's nice. Oh, and also like a phone book. I think that's like a super like a specific one. So that's interesting. We have another question in here. How do you use it on video? I think we can just like download like any video and like input it into the model. I think it also like supports videos like instead of images. Let's see. Yeah, so like it can be like basically run prediction images, videos, directories, streams. So you can also like add it to a video path and like it should also work in there, which is also like it's also like cool enough. Great. So let's call our function in here, and let me see how Python arrays were done. So Python array syntax. Oh, oh, then it doesn't matter. Like I don't have. That's true. I don't have to declare like the type, so I can just leave it as class names and then just like pass on like these to my function in here. But I'll just leave this. I'll delete this because I will be calling this function on my on the streamlit. So I'll just delete this one over here and then just change these to class names. And then this one will also be class names. And image path, it's basically going to be replaced over here. There we go. And I'm still missing to see what to do about this. Let's see what we can do about that. For now, we're going to let's see if we can return like this. So return results dot show and see what happens. So let's go back to our app and now import our function. So from oh, I can just import it as a file. So import. Well, no, sorry. From YOLO ePrompt. So YOLO, and let me rename these to like lowercase. Rename, because then I will have issues with the import. YOLO prompt. And I'm going to do this YOLO lowercase prompt and then import. What was my function called? So it was detect classes. Detect classes. There we go. So now let's call our function in here. So detect classes. And we're going to pass on the two things. So my classes and then my file. There we go. And these we're going to store it. I don't know if we can store it like on an instance of like we can try doing like st image and then just passing like this whole function, but honestly I don't know if that's like legit. We will try it, but like I'm flagging that we might have like some errors on this. So let me go back to the dashboard itself and refresh my screen, and also I will upload the script uh, to the Discord in there. Okay, so let's try uh, with monitor because we know that one works. So monitor and then browse files, and let's try messy desk, open and launch YOLOE. Oh yeah, it's invalid for input size. So yeah, I think the error is on the image thing. So let's try to see. Let me actually first like upload these so like you can have the dashboard part. Let me also copy relative path so you can also have, so I don't upload like the actual models on the copy relative path, git ignore. Hmm, there we go. So added um, free prompt. There we go. So now you should be able to see like this changes on the GitHub in case you want to. And let me try um, YOLOE prompt. So these results are not working because it's like a local image. So let me try fixing this with Copilot. 30 wishes. Yeah, because like the image thing is like kind of like weird. Or what we can try is like saving the image and then like actually displaying it. That's also another thing that we can basically do. So I'm going to pass on like the shape, like an example shape to like Copilot to let it know that this is like the shape of my image. Um, so I have this error for the image shape that I want to display on my Streamlit dashboard. There's a question. Can you upload YOLOE.py where we just type the names also to GitHub to run in Colab? It's probably on your commit history. I think it's the same one. Like you can. I mean, I can add it as a comment in here in case you want to try it out. I'll just add like a comment section here. So it was. You can do like class names, and then do like equal, and then do like here and put like cat, and then like dog, and that should work for you. In here you just will need to like replace this with a different name and also like the variable in here. So like you can do in here like test classes, and then just type in like test classes in here and also replace them in here. And I'll also add as context my Streamlit dashboard over here. So honestly, Copilot it's a nice tool. You can get it for free as if you're a student. You can go like GitHub Pro, and it also gives you like other cool tools. It's telling me to plot them. I don't think it's going on the right direction here to get annotated image. I mean, let's try it. It seems like an easy solution, but I don't know if that will work. Like this thing that we're doing here for the ST image and then this, I don't think that's legit. That just looks weird. So upload example for written classes. So there you go. I uploaded the comment with the other classes in there. And let's try refreshing our app so we can see if like this is working. So monitor, then browse files, and then messy desk. Open, launch YOLOE. It's still like same error. Honestly, I've never run it like on the Streamlit. So yeah, this was not like going to be working. Because I think the ST image just refers to like the downloaded image and then like like an array of the image, but like the way that it's done with the YOLOE, it's not like working correctly. Mm, mm, I don't like this like at all. Yeah, but I'm like doing that correctly. Like I'm just basically writing like a single input in here. Oh, probably because I have to type it differently. Copy paste the entire error to give more context. Yeah, we can try that. This is one of the first times that I've used like AI on like a stream. I don't usually like to do it, but like right now, I think I'm like sleepy enough to like try to think by myself. So I just let the AI work. This error means that the class names or text argument passed. It's not a list. Oh, okay. It's just like, yeah, makes sense. Makes sense. I mean, this is like unrelated to like the error that I thought it would be. Like I thought the error would be related um to like doing the display of the image, but I think that's not like the error there. Let's just see if that was it. It would be too good to be true if this actually worked, because like we are about to like wrap up the stream now. Let's do messy desk, launch YOLOE. Great, we have a different error message. Unsupported image type. For supported types, see. Okay, let's see like the supported file images. Perhaps like the Streamlit is like converting it to a different like type. Honestly, this is like zero helpful. This is like zero helpful. Ah, there we go. Oh, you can also like pass on like a URL for a YouTube video. That's interesting. That's nice. Okay, I'll just tell it to convert it to like convert it to like this format. And then I'll just pass on the other error that was there. Um, let's see. And let's visit our VS Code pets in here. There's a cat over here. It's very nice. When using Streamlit's file uploader, the uploaded file is a file like object, not a file path or NumPy array. Okay, so peel image was supported and NumPy array was also supported. So I think we're going on a right path. Let's try this now. So it's the same, but now we are basically converting it to a peel image. Let's see if peel image works, and if it doesn't work, then we'll just try to download like the image to our local computer and then just like display it from there. I know it's not like the best solution, but like at least it's the solution that I'm thinking of like right now. So monitor, and then browse files, messy desk, open, launch YOLOE. Oh, there we go. Class is created. So now after two prompts and some debugging by ourselves, we were able to run like the YOLO model like on the dashboard in here. I'm just going to deploy this super quick so you can also like view it like on your houses or like on your computers as well, so you can also like test the app. Requirements.txt, and I'm also going to show you in this like 5 minutes that we have left that it's like super easy to deploy an application on Streamlit. So I'm just going to leave it as it is. I just basically created a requirements file because that's like necessary for deploying an application on Streamlit, and I'm just going to commit it to my repository. The thing with Streamlit and why I like it so much is because you can basically deploy it super quick from your GitHub repository. So if you have like a GitHub repository and you want to deploy your application from there, you can do it like directly. So in my case, I only clicked on deploy and then I'm able to deploy it from here. So it automatically selected the repository that I'm using. It selected my branch and also my main file path, which is the app.py. Then I can select my app URL, which is just basically the domain name. I'm going to call it YOLOE Global Hack Week. And then I'm going to hit deploy. And you'll see that this is like super easy. Like it will just start like downloading all of the dependencies and like making sure that I have like no errors on my app. And in case that there are like some errors, they will be shown on the console over here. And honestly, that will be, I think that will be all. Like all of the code, it's on the where was the GitHub? So all of the code will be like on the repository for YOLOE. So it just basically like here you can see like all of the files that I've been testing, and I'm also going to add like the demo link over here in case like you want to try it. So where was it? It's still like it's installing. It's doing the PIP install. Which version of YOLO are you using? So right now I'm using YOLOE, which is like a new zero shot computer vision model to detect like classes that it has never like seen before. So yeah, that's the versioning. This is taking a while. I don't know if it's because the ultralytics library it's like super heavy, and also like the models that are in there. I think it's actually like downloading the models. So I'm just going to drop the domain name over here and paste it on our GitHub repository. Right now it will still be loading, but like in a few minutes perhaps, like you might be able to like actually try it out. Let's see. Oh, no, this is a local host. I was like, oh, there it is. Process dependencies. So now the only thing that's missing, I think it's like downloading the models, which should be done like by now. Those Streamlit provide GPU or it's just only CPU. So CPU only. Yeah, I'm basically running these like on my computer like itself. I don't think they support GPU usage. This app has encountered an error. Mm. Oh, I think it's the models. Like I think I need to upload them. But I don't want to do that. Yeah, I think I have to upload the models to the GitHub. I'll try to do that like after the stream to see if like GitHub allows me to like upload the files. I think they were not like so heavy. So like we shouldn't have an issue, and then I'll refresh like the application so you can actually like test it out. So I already left for you this link on the GitHub in case that you want to visit it like you know sometime later today as well. But yeah, basically that will be all from me today. I know this was kind of like a long stream and we saw like a lot of technical concepts. So tomorrow I will be basically giving two parts of like different streams. So I'm basically going to be giving on the last day, which is like day 6. I'm going to be giving the one of voice power GenAI with Bapi, part 1 and part 2. They will be like close to like each other, so it will be a lot of things that we're going to do there. So I'm going to try to focus more on the coding project in there. Because like at least for now for the YOLOE, like I really wanted you to understand what zero shot was, and also like to learn what was on the backbone of YOLO itself, in case of that you start using it like on the future projects and so on. um but for these other like two streams, which are basically these ones, so the voice powered Gen AI with Bapi part 1 and part 2, they're going to be at 3 p.m. CST. If you open up the schedule on your computer, it should tell you like the time zone, and display you the time that you're actually like in. Yeah, I will focus more on doing like a cool project in there rather than explaining, because I really think there's not so much to explain like from these tools, because they're like general tools. So I'll just keep it like I'll just give like a brief presentation, and then we'll just focus more like on doing like a cool portfolio project for your curriculum as well. Yeah, thank you so much for having me today. I'm so excited to be back at Global Hack Weeks. And I'm pretty sure if you have time tomorrow, please join the stream. And don't forget to check in again to this current stream in case that you want to have the point for your Global Hack Week. Want some end-to-end production grade projects if possible? I mean, I will do my best. If you have any ideas, feel free to DM me on Discord, so I can prepare something that will be helpful for you all as well. Yep, I'm always open to like new streaming ideas or cool projects that you want to build, so I can do them on stream, or like a new technology that you want to try out. You can send me your ideas on Discord, and I can review them and see if that like there's something that we can do about them as well. So thank you everyone, and have a nice day or a nice morning, or in my case a good night, because I'm going to sleep right now, and I'll be back with you tomorrow with more cool content on this Global Hack Week. Bye everyone, and I'll see you tomorrow.